So welcome to this video. Don't let all of this writing intimidate you. If you'd like to copy it down into your notes, go ahead and pause the video right now. Copy it down in your notes. The quotient rule is not as pretty as the product rule. The numerator is almost identical, but it does have a subtraction sign. And now there's a denominator in our derivative. Okay? So don't worry, there's a little jingle that helps us remember this. So again, it's derivative of the first times the second minus now the first times the derivative of the second. So the numerator is almost the same as the product rule, just with subtraction. And the denominator is the bottom function squared. So if f is our top function and g is our bottom function, a lot of times how we phrase this is low d high, so d meaning derivative, low times the derivative of the high function. D is the low one, f is the high one. So we say low d high minus high d low, square the bottom, and away we go. So I hope you're ready to hear that little jingle a lot in this section, because I'm going to be giving it to you. All right, so there's a couple ways of thinking about it. You need to think about it as a product rule with subtraction divided by g squared, or you can use a little jingle. And now is not the time for cat pets. I apologize. All right, here we go. Let's use this, see it in action. Example 3. Uh-oh. All right, we're having an issue. I'll blame my cat for that one. Give me 1 second. Nothing to see here, everyone. Another math video going according to schedule. All right. All right, it is just doomed, right? Aha! Here we are. Perfect. Let's do an example. Example number 3. Find y prime. All right, so let's look at these. Part A. Y is equal to x divided by 2x plus 3. So again, we have to use the quotient rule here because we have a quotient of functions. This is a rational function. It is a line over another line. Okay. Another way to do this actually would be to use long division, but we're not going to do that. So our top function is f. Our high function is f. Bottom function is g. So to find y prime, we're going to use that little jingle. We can say low d high minus high d low, square the bottom, and away we go. Here we go. G, right, that's just 2x plus 3 times f prime. The derivative of our numerator, the derivative of x, is just 1. Minus the top function, which is x, derivative of the bottom function is 2. The bottom function is a line. The slope of the line is 2. Divided by the bottom function squared. Here we really are going to want to simplify a little bit, but it's not that bad. All right, this will be 2x plus 3 minus 2x over the denominator, which is 2x plus 3 squared. And again, we have a plus 2x and a minus 2x, so that just cancels. We're going to get 3. Let's include this all on the same page. We're going to get 3 divided by 2x plus 3 squared. That's a quotient rule. Just remember the little jingle, plug things in correctly, and you're good to go. We'll do 2 more problems though, just to show stuff that can get a little messier. We have y equals x cubed over x squared plus 1 to the 4th. And again, right? X cubed, that's our top function. X squared plus 1 to the 4th, that's our bottom function. So y prime is equal to low. Again, g is low, f is high. Low d high minus high d low. Square the bottom, and away we go. So the bottom function, that's x squared plus 1 to the fourth times the derivative of the top function. The derivative of x cubed is 3x squared minus the top function, which is x cubed, times the derivative of the bottom function. Be careful here. We need to take the derivative of this guy, general power rule. 4 comes down, inside stays the same, subtract an exponent, and multiply by the derivative of the inside, which is 2x. All over, oh my word, that fraction bar got really tilted. All over the bottom function squared. And again, be very careful. The bottom function is x squared plus 1 to the fourth. And we're squaring that function. We're going to clean these ones up. Okay. So let's look at things. This first term, we'll just write that as 3x squared times x squared plus 1 to the fourth. The second thing, right, we can combine all the monomial parts. This is going to be 8x to the fourth. And then x squared plus 1 cubed. The denominator we can also simplify, right? We have an exponent and another exponent. We'll multiply those exponents to get x squared plus 1 to the eighth. Now, I want to cheat a little bit. I'm going to cheat a little bit. I'm just going to move the camera a little bit so I don't have to copy this down. To simplify the numerator, we're going to factor out an x squared plus 1. Right? Because notice both numerators have this x squared plus 1 factor. In fact, the first one has it 4 times, the second one has it 3 times. So we can actually factor out 3 of them. So if I factor out 3 x squared plus 1s, then what's left from this term? So the 3x squared and another x squared plus 1. Over here, if I factor out 3 x squared plus 1 factors, we're left with a minus 8x to the fourth. And then we factor out all the rest. And look at what this is going to allow us to do. Our denominator is x squared plus 1 to the eighth. So if we have things factored, we can cancel common factors. Then the numerator, right? 3 of these are going to cancel with 1 of these. All right, I'm going to do my best. I practiced this. Let's see if it's going to work. We're going to say this. Add to new page. Hey, how about that? So this is our derivative. We'll have this on the next page. And then we'll continue. All right, we got a little bonus stuff with us. And now we don't have to worry about, oh no, I can't erase it. All right, this is a low quality video. Y'all are having a low quality math class today. Anyway, so that's our derivative. We can simplify a little bit more, right? We can simplify this inside up here. Distribute that 3x squared, right? Because when I distribute this 3x squared, look what happens. We get 3x to the fourth plus 3x squared minus 8x to the fourth. This is exciting. We got like terms in the top, right? 3x to the fourth minus 8x to the fourth. Oh, it is simplifying. Not super nice, but a little bit. We're going to have negative 5x to the fourth plus 3x squared. Look at that. That is nice. Over x squared plus 1 to the fifth. Nothing else cancels. Nothing else. We could factor the numerator if we wanted to. I'm really trying to turn my denominator. I'm trying to make this look like a 5. This is, we'll call this scuffed math lectures. But nothing will cancel, so this is where we'll end. Fun stuff. Simplifying just means combine like terms and then factor and cancel. So remember that. Combine like terms, factor and cancel when you're simplifying these fractions. All right, last problem is a real doozy. Last problem is going to be part C. Y is going to equal the square root of x squared plus 7 over x plus 1. And now there's a couple of ways to approach this problem. You could combine the general power rule with the quotient rule, or you could rewrite this first. I'm going to rewrite this first. So the square root is the same as an exponent of 1/2. So the top has a square root applied to it, and the bottom also has a square root to apply to it. This is one way to start this problem, and then use the you can use the quotient rule. But what I'm going to do is I'm just going to start taking the derivative. Let's just kind of write this out in steps. So write this as x squared plus 7 over x plus 1 to the 1/2. We use the general power rule plus the quotient rule. The 1/2 comes down, the inside stays the same, and we subtract the power. The inside stays the same, means we still have an x squared plus 7 over an x plus 1. But general power rule says we have to multiply all this by the derivative of the inside. And I'm just going to write derivative of the inside. Because we'll have to use the quotient rule on the derivative of the inside part. And this is where things get wacky. All right, so again, this top function, that's going to be our f. Bottom function, that's going to be our g. So this other thing, right, this thing right here, that just stays where it is for a second. Let's really focus on this thing over here, and then we'll combine it all. So our derivative, let's go. What a fun problem. Our derivative is equal to 1/2. What does this negative exponent here mean? It means reciprocal. We could change this to a positive exponent and take the reciprocal of the inside if we'd like. I'm gonna hold out on that. No, I'm gonna do it now. All right, so we're gonna have x plus 1 over x squared plus 7, the positive 1/2. Now we need to take the derivative of the second thing. It's going to be low, which is x plus 1, d high, which is 2x, minus high, x squared plus 7, d low, derivative of the bottom is 1. Square the bottom, and away we go. That wasn't too bad. Simplifying this probably will be. But that other part wasn't too bad. So let's simplify a little bit. We're going to get y prime equals 1/2. And I'm going to rewrite this first thing a little bit. X plus 1 to the positive 1/2 divided by x squared plus 7 positive 1/2 times this other fraction. We'll distribute that 2x. We get 2x squared plus 2x. Distribute that negative, minus x squared minus 7. And the bottom we'll keep as x plus 1 to the tooth. So already we have a little cancellation. Right, we're multiplying two fractions together. The bottom fraction, I have 2 of these. Top fraction, I have half of one. So we'll cancel half, and the 2 gets lowered by 1/2. The 2 becomes 3 halves, or 1.5. We're already getting a little bit going on here. Again, I'm just going to lower this a bit. What we're going to get is we still have 1/2 x squared plus 7 to the 1/2. Let's look at this numerator. What happens? We have 2x squared minus 1x squared. It's going to leave us positive 1x squared plus 2x minus 7. I feel like I made a small mistake somewhere. If you're looking at this video and you see a small mistake, please let me know in the comment on the video. I thought something better happened. Let me just double check real quick. We're taking the derivative of x squared plus 7 over x plus 1. We have low. low d high, that's good. Minus high d low, that's good. Square the bottom. Distribute the 2x to become 2x squared plus 2x. Distribute the top, minus x squared minus 7. Now everything looks right. Yeah. So yeah, this one doesn't simplify very nice unless I did make a mistake. But we're almost done. We're going to multiply these together and get the numerator, which is x squared plus 2x minus 7, which doesn't factor. And the denominator, which is going to be 2 times x squared plus 7, the 1/2, times x plus 1, the 3/2. I'm almost positive I made a small error somewhere. Again, if you find it, feel free to let me know. If you find an error in this problem, comment. Anyway, that's a quotient rule. Good luck. All right, so this really is just like the messiest thing that you can find in this section. I just wanted to give a little example here. And yeah, just be careful with your fractions, be careful with your distributing, careful with whatever I may have done. And let me know if you have questions.